uniform circular motion. If an object is moving in a circular path at constant speed, that motion is called a uniform circular motion. For example, here this object is moving in a circular path of radius r. Okay, so at each and every point, what happens? The direction of motion changes. For example, if the object is moving in anti-clockwise direction like this, here the direction of velocity is along the tangent. Clear? Here what is the direction of velocity or direction of motion is along the tangent. Here the direction is along the tangent. Each and every point the direction of motion changes, or the direction of velocity is along the tangent to the circle at that point. And here radius and velocity are mutually perpendicular to each other. So that is the importance of uniform circular motion. So in a uniform circular motion, even though the magnitude of velocity or speed remains constant, the direction of velocity continuously changes. So when an object follows a circular path at a constant speed, the motion is called uniform circular motion. Here the speed of the motion is constant, but the direction of motion continuously changes, and the direction of velocity is given by the tangent drawn to the circle at that point. So the direction of velocity is always along the tangent to the circle at the point. Clear? Now the direction of velocity vector is always perpendicular to the radius vector. As you can see in the figure, radius vector and velocity are always mutually perpendicular. So only in a uniform circular motion, radius vector and velocity are mutually perpendicular to each other. Due to the velocity change produces an acceleration. So if we know that whenever there is change in velocity, there is an acceleration. Here the magnitude of velocity or speed remains constant, but direction of velocity changes, which give rise to acceleration. Hence uniform circular motion is called an accelerated motion, because even though magnitude of velocity remains constant, direction of velocity changes, which give rise to an acceleration, and hence uniform circular motion is called an accelerated motion. Now why it is called uniform? The word uniform refers to the speed. Magnitude of velocity remains constant, isn't it? Hence the speed remains constant. It is called a uniform motion, uniform circular motion. Clear, children? In a uniform circular motion, we know that acceleration remains constant, isn't it? That acceleration is called a centripetal acceleration. Okay, now we can derive the formula for centripetal acceleration. So consider an object moving in a circular path, for example in anti-clockwise direction. Okay, now an object is moving in a circular path in anti-clockwise direction, and the radius of the circular path be r. Okay, and the particle is moving with a constant speed v. Let p and p dash be the initial and final positions of the particle at any instant. Okay, at two instants, the position of the particle be p and p dash. The corresponding radius vectors be vector r and vector r dash. Here p is the position and the position vector be op, that is vector r. And after some time, p dash be the position and its position vector be op dash, and the vector is vector r dash. Position vector is vector r dash. Clear? So vector r and vector r dash be the position vectors, and at the point p, what is the direction of velocity? We know that it is along the tangent, isn't it? So this is the direction of velocity at the point p. And what is the direction of velocity at the point p dash? This represents the velocity at the point p dash, okay, along the tangent. So r and r dash be the position vectors and v dash be the velocity vectors at the points p and p dash. So this is the assumption. So once more, consider a particle moving in a circular path of radius r, p and p dash be the two positions of the particles. Okay, then with the velocity vector vector v and vector v dash, and with the radius vector position vectors vector r and vector r dash. Magnitude wise vector r and vector r dash are equal. Okay, both represents the radius, but direction wise they are different. So magnitude of r and r dash are equal because both r and r dash represents the radius vector. Now delta theta be the small angle subtended at the center by the two position vector. So when the object particle moves from p to p dash, it subtend an angle at the center, and that angle be delta theta, small angle delta theta. Clear? Then delta r represents the displacement vector from the initial position to final position. The displacement vector between P and P dash be delta r. Now we can consider the two triangles. First triangle is with position vectors. So what are the two triangles here? Initial position is O. Okay, OP represents the first vector, OP dash is the second vector, and from P to P dash there is a displacement vector, that is delta r. From initial position to final position there is a displacement vector, that is delta r. So this can be redrawn like this: O, P, P dash. OP represents the initial position vector which is given by vector r. This is vector r, this is vector r dash, and this is the displacement vector. Clear, children? And the angle subtended at the center is delta theta. Similarly, we can draw velocity vector like this. Similarly, at the point O, P, here P dash, corresponding to OP, there is a velocity vector, vector V. Okay, so corresponding to OP, there is a velocity vector, vector V. Corresponding to OP dash, there is a velocity vector, vector V dash. Corresponding to P, P dash, there is a change in velocity, delta V, that we cannot mark here in the original figure. So corresponding to R, there is a velocity vector, vector V. Okay, corresponding to vector R dash, there is a velocity vector, vector V dash. And similarly, corresponding to the displacement vector, there is a velocity, change in velocity vector, delta V. Clear? So what is the angle between here? This is also delta theta, because this velocity is due to the position vector r. If there is an angle between r and r dash, that angle is delta theta. Surely there is an angle between vector v and vector v dash, and that will be delta theta. Okay, so consider these two triangles produced by velocity vectors and position vectors. The triangles formed by position vectors and velocity vectors, these two triangles are said to be similar because magnitude wise r and r dash are equal. Here also magnitude wise vector v and vector v dash are equal. Magnitude of velocity is equal, no? In a uniform circular motion, speed remains constant. So v and v dash magnitude remains constant, same. R and r dash magnitude remains same. The corresponding angle delta theta also same in both the triangles. Therefore, these two triangles are said to be similar. Right. Now, we can the condition for similarity of the two triangles, we can write V divided by R. Okay, V by R equal to V dash by R dash equal to delta V divided by delta. The sides are proportional, that is the condition. So, V by R equal V dash by R dash equal delta V divided by delta R. So, the two triangles are said to be similar. We can write V by R equal to V dash divided by R dash equal to delta V divided by delta R. Now, we can take these two terms, V by R equal to delta V by delta R. So, we can write equal to delta V divided by delta R, or delta V can be written as, what is delta V? Delta V equal to V by R into delta R, isn't it? Delta V, change in velocity, is equal to V by R into displacement. Now divide the whole equation by time, delta t. Let the object moves from P to P dash in the time delta t. Okay, we have the initial position P and final position P dash, and the object is moving from P to P dash in a time interval delta t. Now we can divide the whole equation by that time delta t. So we can write delta V by delta t equal to V by R into delta R divided by delta t. What is this delta V by delta t? Change in velocity by time. Rate of change of velocity is acceleration. Clear? Equal to V by R into, this is the rate of change of displacement. Displacement by time, that is velocity. So acceleration is given by V square divided by R, and this acceleration is called the centripetal acceleration. Hence it is represented by AC. So A suffix C, centripetal acceleration, is equal to V square divided by R. Clear children? So the formula for centripetal acceleration is v square divided by r, where v represents the velocity or magnitude of velocity, that is speed, and r is the radius of the circular path. So centripetal acceleration is given by v square divided by r. So whenever an object is moving in a circular path, the centripetal acceleration is given by v square by r, and what is the direction of the centripetal acceleration? Direction is always towards the center. Centripetal. The direction of acceleration is towards the center, therefore it is called centripetal, towards the center. So centripetal acceleration is AC is equal to v square by r, and its direction is always towards the center. Okay children? Now there is another way of describing the velocity and acceleration of an object in uniform circular motion. For example, if an object is moving from P to P dash in time delta t. Okay, the line OP subtend an angle theta, delta theta. Here the angles OP subtend an angle delta theta at the center. And this angle delta theta is called angular displacement. We know displacement in linear motion, we know what is displacement. Okay, so here if an object is moving from one point to another point in a circular path, it subtend an angle at the center, and that angle is called angular displacement. The rate of change of angular displacement is called angular velocity. We know velocity in linear motion, velocity is displacement divided by time. In angular motion or in rotational motion or circular motion, angular velocity is represented by omega. Omega is represented by angular displacement divided by time, and its SI unit is angular velocities, the angular displacement divided by time. Angular displacement SI unit is radians per second. So SI unit of angular velocity is radians per second, and it is represented by the Greek letter omega. Now we can derive the relation between angular velocity omega and linear velocity v. Relation between linear velocity v and angular velocity omega. Okay, so we can consider same figure. Delta theta is the angular displacement, that you know. Angular displacement is angular displacement, we can write angle is equal to theta is arc divided by radians, isn't it? Angle is equal to arc. Arc is pp dash. pp dash is equal to displacement, isn't it? So angle is equal to arc divided by radius. Therefore we can write here delta theta, the angular displacement delta theta can be written as pp dash. pp dash is equal to what? Displacement, isn't it? Angle is equal to arc divided by radius. That means delta r divided by, what is the radius here? R. Okay, r and r dash magnitude wise both are equal. That represents the radius of the circle. So divided by r. So we can write angle is equal to arc divided by radius. So delta theta is equal to delta r divided by r. Clear? Now we have angular velocity omega is equal to delta theta divided by delta t. We know angular displacement omega equal to delta theta divided by delta t. We can substitute here, therefore omega equal to delta theta can be written as delta r by r. So delta r divided by r into delta t. What is this delta r by delta t? Delta r by delta t is displacement divided by time, isn't it? Displacement by time is velocity, the linear velocity v. So substituting we can write therefore omega equal to delta r by delta t is v. So v divided by r, or v is equal to r omega. So the relation between linear velocity v and angular velocity omega is v equal to r omega. V represents the linear velocity. That means the velocity with which the object is moving along the circular path, and omega is the angular velocity. Linear velocity v equal to radius into angular velocity, v equal to r omega. And this is the relation between linear velocity and angular velocity. Using this formula we can write acceleration, we can write the centripetal acceleration. We know centripetal acceleration is equal to AZ equal to v square divided by r, isn't it? Or AC can be written as, what is v? Using this angular velocity we can write v equal to r omega. So V is equal to r omega, substituting r omega the whole square divided by r. So centripetal acceleration is also given by r omega square. Clear? So the formula for centripetal acceleration relating angular velocities is equal to r omega square, relating linear velocities is equal to v square divided by r. In 9th standard you have studied what is time period. Time taken by an object for one complete revolution. For example, if an object is moving in a circular path, time taken by the object to complete one circular path is called a time period. Its SI unit is second. And the number of revolutions in 1 second or number of circular path in 1 second is called frequency. It is represented by the Greek letter nu, and what is the relation between frequency and time period? That also you know, nu equal to 1 by t. And its SI unit is, frequency SI unit is hertz. Okay children? So time for one complete revolution is called a time period, and number of revolutions in 1 second is called frequency. Frequency is represented by nu, Greek letter nu, and the relation between frequency and time period is nu equal to 1 by t, and its SI unit is second raised to minus 1, 1 by 2 t, no. So second raised to minus 1, and it is called hertz. And we have the relation between the angular velocity omega, omega is called angular velocity, and frequency, the relation is omega equal to 2 pi nu. Okay, omega is relation between angular frequency omega or angular velocity. Omega is also called angular frequency or angular velocity. So omega equal to 2 pi nu. This is the relation between angular velocity and the frequency, or angular frequency and the normal frequency. Clear children? So omega equal to 2 pi nu. Now we have the linear velocity v equal to r omega, no, is equal to r into omega, that is 2 pi nu. So velocity can be written as 2 pi nu into r, radius of the circle. We have the acceleration, centripetal acceleration AC equal to v square divided by r. So it can be written as v is 2 pi r nu the whole square divided by r. Clear? So it can be written as is equal to 4 pi square r nu square. Clear? So this is the formula for centripetal acceleration relating frequency. So there are three formula for centripetal acceleration: AC equal to v square by r. Now AC is equal to r omega square, or AC is equal to 4 pi square r nu square. Clear? So this is the formula for centripetal acceleration relating velocity, linear velocity. This is the formula for centripetal acceleration with angular velocity. This is the formula for centripetal acceleration with frequency nu. Okay children?